Welcome to a mechanical masterpiece. We are analyzing the amphibious vehicle prototype. Pay close attention to the environmental transition. The dual pontoon system provides immediate buoyancy, an extremely powerful hydrodynamic thrust as the rear wheel is tuned into a high-speed rotating fan. The generated thrust completely overpowers the water's resistance, helping the vehicle move stably on the river surface. The ability to balance the center of gravity of this homemade pontoon system is truly an incredible engineering achievement. But where did this whole project begin? Let's go back to the starting line with the old Honda Wave frame. Our engineer is pulling the frame out of the scrapyard. Despite the rusty exterior, the engine is still full of potential. The restoration process begins by freeing the mechanical system from the surrounding obstacles and trash. The prototype is brought into the workshop. The first diagnostic step is to check the CDI ignition system and the overall power supply. 4. Turn on the ignition key, activate the Kickstarter to directly check the compression ratio of the combustion chamber. Absolutely fantastic. The engine block has successfully burst into power. The engine block still works perfectly despite the time. The RPM sound is very even and stable. This is a clear testament to the system's mechanical durability. Three, the first fabrication stage officially begins. The engineer dismantles the exhaust system using specialized tools. The old exhaust position is too low and will cause hydrolocking when waiting. This component cluster needs to be completely restructured. Moving on to the metalworking stage, the arc. Start cutting thin cardboard to sketch. Welding machine is used to cut and rejoin the steel pipe at a new angle, using a wire brush to clean the welding slag. The exhaust pipe is now pointed upwards to avoid sucking in water. Proceed to reassemble the newly fine-tuned exhaust manifold cluster. This snorkel design will safely protect the combustion chamber. Tighten all load-bearing bolts to ensure there are no gaps causing exhaust leaks under high pressure. Moving on to the propulsion module, release all pressure from the rear tire by removing the standard metal valve core. Using a lever, a specialized tire iron to pry off the rubber bead. This operation requires applying significant mechanical force, completely removing the outer tire and the inner tube. The spoked rim frame will be redesigned as the rotor. Shaft for the propeller. A physical template for the hydrodynamic propeller blades. Use the cardboard template to mark the steel plate, preparing to shape the propeller blades. Using a specialized handheld angle grinder, precisely machine and cut out each steel blade. The flying sparks show the high hardness of this carbon steel material. Use a sledgehammer and anvil to bend the steel blade, optimizing the hydrodynamic water entry angle. Arc weld the propeller blades onto the spoked rim, creating an extremely solid mechanical bond. Check the weld penetration using a lever to ensure it withstands maximum engine torque. brush off the welding slag, and spray anti-rust primer, an essential step to protect metal underwater. The engineer begins stuffing the rubber inner tube back into the rim, handling it skillfully to avoid tearing the air membrane. Keeping the inner tube helps maintain the wheel diameter and reinforces the rigidity of the propeller rim. 4. Tighten the metal valve core with a specialized tool. Preparing for the high-pressure air compression process, use an air compressor to inflate the inner tube. The inflated tube locks the propeller blades firmly in place. Start the engine for a practical test to verify the thrust. The engine transmits power smoothly to the propeller rim. The high-speed rotation operates extremely stably with absolutely no dynamic imbalance phenomenon. Moving on to the flotation module, the core of the project, the engineer measures the rectangular composite pontoon dimensions. The three-dimensional parameters are measured highly accurately, serving as the basis for volume and load calculations. Entering data into a smartphone calculator app, the system outputs the theoretical maximum lifting capacity. According to Archimedes' hydrostatic principle, each of these pontoons basically provides up to 71 kilograms of buoyancy. Theory always needs to be verified by practice. Bringing a pontoon directly to the riverbank for testing, dropping the composite block into the murky river, the Archimedes thrust works perfectly. The pontoon floats buoyantly. Using full body weight to press the pontoon down hard, a very rigorous static load-bearing test. 4. The pontoon strongly resists with very little sinking. The actual buoyancy completely exceeds expectations. 5. Pulling the pontoon ashore to prepare for the next stage. Next is the step of reinforcing the waterproof layer. Starting to sand the surface of the composite pontoon. Using a drill equipped with an industrial sanding disc, sanding vigorously to create adhesion, a thick cloud of dust fills the air. Proceeding to mix the materials, the engineer carefully pours the pink resin solution from a large jug into a plastic cup, preparing to create a waterproof membrane, spreading the fiberglass reinforcement mats onto the pontoon, using a brush to generously apply the resin for deep penetration. This process turns the fiberglass into an outer shell that is extremely rigid and completely waterproof. Stirring the black resin mixture with a chemical catalyst inside the yellow bucket. This thick, viscous glue will serve as the final finishing coat. Meticulously brushing the black resin over the entire pontoon system, the rough composite surface is quickly covered, becoming smooth and glossy black. The 2 buoyancy pontoons are now ready to face the aquatic environment. Returning to the land mobility system, the engineer uses an arc welder to firmly attach the multi-directional wheel assemblies to the metal brackets. Skillfully pouring high-strength adhesive onto the pontoon, placing the newly welded wheel assembly on top, then applying more black resin mixture to seal it completely. This landing gear system helps the vehicle move smoothly on land. beginning the assembly of the front pontoon module onto the vehicle, lifting the front wheel and carefully sliding the metal bracket right onto the front suspension fork, tightening the bolts and test spinning the wheel. The connecting brackets are securely fastened. Moving on to the side pontoon modules, the engineer is meticulously aligning the steel bracket frame to the footrests and the motorcycle's rear swing arm, using a wrench to tighten the nuts, creating a solid mechanical anchor point. Lifting the entire side pontoon block and skillfully sliding the metal connecting rod into the newly installed brace. Aligning the cross-bolt positions, the rear load-bearing swing arm structure is gradually forming a synchronized unit. Continuing the metal cutting process, starting the metal chop saw, the alloy saw blade cuts through the square steel bar, creating bright electrical sparks. Drilling, positioning holes, then spraying on a black anti-rust coating. Starting the arc welder to securely attach the brace to the rear pontoon frame with welding sparks flying everywhere. The engineer slides in the longitudinal reinforcement bar, anchoring it directly to the motorcycle's luggage rack. Tightening the bolts creates a perfect anti-torsion frame. Using an angle grinder to smooth out excess material, completing the final cross brace. The side pontoon structures are now locked tightly to the vehicle's body. And here is the completed amphibious mechanical masterpiece. The front pontoon, side pontoons, and propeller system are fully assembled and ready to defy the limits of physics. Stepping onto the bike and kicking the starter lever hard, the engine roars to life. Shifting gears and twisting the throttle, the multi-directional wheel system under the pontoons helps the machine roll smoothly across the concrete. The vehicle speeds along the asphalt road, heading straight for the embankment. Its multi-terrain operational capability has been successfully confirmed in this initial stage. A historic moment, slowly lowering the prototype onto the river and gunning the throttle. The propeller tears through the murky water, shooting out a giant column of water behind it, with incredibly brutal thrust. The hydrostatic lift from the 3 fiberglass-coated composite blocks keeps the vehicle floating with complete stability. It is gliding across the water as smoothly as a motorboat. Gently weaving past patches of water, hyacinth, and moored barges. The front wheel steering mechanism parts the water with highly precise feedback. The engine operates reliably with no signs of hydrolocking. Observing the thrust from the rear wheel, the furious RPMs are spinning at maximum speed. The steel blades grip the water well, converting all torque into forward acceleration. parading around the wooden pier area, the wide stance of the side pontoons completely eliminates any wobbling, keeping the vehicle's center of gravity perfectly balanced. An outstanding mechanical crossover modification between a two-wheeled vehicle and a boat.